In 18.7, we are solving radical equations. So kind of the natural course of the last 3 chapters has been we introduce something, we perform some operations on it, like adding, subtracting, multiplying, dividing. We then move to actually solving equations, and then we would finish with word problems. Now I told you guys there's no word problems on this test, so we'll have those on the next test. But we are going to do equations, all right, radical equations. Now, to do this, I want to actually kind of start with some split screen action here. Line tool. If I gave you x equals -3. What's the solution to that equation? X equals -3. Right? If I gave you the equation x squared equals 9, that's quadratic now. And so far, although one of you tried to do a method we haven't covered in class yet on your test, and you didn't do it successfully. Right? How would I solve this? How would we solve a quadratic? No, we haven't talked about that.
Isn't it 3 though?
Mm-mm.
X isn't 3?
How do you solve a quadratic so far?
You minus 9.
You bring everything to the other side and get it equal to 0. So x squared minus 9 equals 0, and then you factor completely. Right? You guys remember?
Misery.
Yeah, that's a difference of squares when factoring. So x squared minus 9 is x plus 3x minus 3, and after you factor set equal to 0, then you broke it down, right? So, was the answer 3?
Right there. 3 and negative.
Ah, there were 2 answers, aren't there? There were 2 answers, 3 and -3. All right? Now, if I look, the right side is what I would get if I took that left equation and just squared both sides, right? If I squared both sides of x equals -3, I get x squared equals 9. Now, what was my original solution to this left equation?
X equals 3.
Only -3. Only -3 was a solution on that left side, right? When I squared both sides, did I lose my solution?
You gave one.
Right, I didn't lose it. It's still there, but I picked one up, right? I picked up an extra solution, all right? So, what does this mean about squaring both sides of the equation?
The plus or minus. Not 2.
If I square both sides, will I lose the actual solution?
No.
No. But what could happen?
You get another.
I could pick up extraneous solutions, right? Your book calls them extraneous solutions. Let's call them stowaways. All right? It's more exciting. In this case, +3 is a stowaway. That was not an original solution. But if I squared both sides, I pick it up as an extraneous solution. So, steps for solving a radical equation. So the first thing we're going to do is isolate the radical. Now someone somewhere gave me a bit of a fit because they didn't understand what the word isolated meant. All right? What do I mean by isolating the radical? Get it by itself as the only term. All right? If it has more than one, you pick one of them, and then we're going to wind up lather, rinse, repeat. All right? Once you get the radical by itself, you raise both sides to the appropriate power. How do I get rid of a square root? With a square. How do I get rid of a cube root? With a cube. That's what we mean by raising to the appropriate power. Solve the resulting equation. If there are still radicals, go back, cycle again, right? And then, very, very, very important, you must check your solutions when you're done because you can pick up extraneous solutions, all right? And you know on your test, I'm going to give you extraneous solutions out there, because I'm going to know which ones of you checked and which ones of you just didn't bother. Right? Now, I mean, let's imagine that we're contract assassins. Right? We have targets. When do we go after our target? When it's by itself, right? So you got to wait for that to kind of wander down the dark alleyway by itself, and that's when you take the shot. And you have to use the appropriate bullet. So we'll use square bullets for square roots, and we'll use cube bullets for cube roots. Get it? Get it?
Oh, wow. So creative.
If there are still radicals around, those radicals are our targets, right? Then we got to clean up the mess, get the second target by itself, and take another shot, right? You'll never forget. Don't forget to check the bodies. You're not getting paid if you didn't do a good job. My analogies are just so natural. So let's give this a try. Let's say that I give you as our first equation square root of 9x minus 2 set equal to 2x. So this is a radical equation. How do I know? There's a radical and an equal sign, right? Wink, wink, nudge, nudge. So, in order to solve this, first thing I have to do is get my radical by itself, which it is, right? This is like the easy money target. So it's a square root. What are we going to do? Square both sides. So we will square both sides of our equation. On the left, that means I actually get rid of the square root, which is nice.
So you cancel them.
Indeed, because what's the square of a square root? Itself, free and clear. Right? What happens on the right?
2x squared.
Nope. 4x squared.
Oh, you gotta square the number 2.
Indeed. You square the whole side, so we get 4x squared. You guys with me on this? All right. What kind of equation is that now? Quadratic. And again, so far, we only have one method for solving quadratics, and that was get it equal to 0 and factor. All right. So I'm going to bring everything over to the right, so I'll have 0 equals. I'll keep the 4x squared, and then subtract the 9x and add the 2 over to the right. You guys with me? Proceed to factor, because factoring never goes away. Ever, 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 ever. Ever, ever, ever. Ever. Okay. So we got 1 and 2, definitely. That's the only choice for 2, right?
Yeah.
So that's actually a hint. I know that it can't be 2x and 2x, because that would make a GCF. It's going to have to be 4x and x. That's the only way that doesn't make a GCF, right? If my outer term is negative 8x and my inner term is negative x, that gets me negative 9x, right? And my last, negative 1 times negative 2 is positive 2. Right? So, x equals 1/4 or x equals 2 are my potential solutions. You guys remember that part, right?
Yeah.
So basically, from this part down, we were doing that 2 tests ago. Right? All we've added is this first part. And
You gotta check the body.
you gotta check those bodies.
So which one's the body?
So we have 2 potential bodies there. You go back to your original. Go all the way back to your original equation. And we got 1/4 and we've got 2. What do you want to check?
2.
Of course, right?
So you plug 2 in every x.
That's exactly what we do. So if I plug in 2, that means I have the square root of 9 times 2 minus 2. And I'll put a hopeful equal sign here. 2 times 2. So I plugged in 2 for x. What's 9 times 2?
18.
18 minus 2?
64.
Square root of 16.
4.
What's 2 times 2?
4.
Does 4 equal 4?
Yes.
So that one was the legit solution. Let's check x equals 1/4, right? I give you the illusion of choice. I just put it off for about 30 seconds. So we've got the square root of 9 times 1/4 minus 2, and we're hoping that that comes out to 2 times 1/4. You guys see what I did there? So 9 times 1/4 is 9 over 4. In order to subtract, I need a like denominator, right? Common denominator. So I'd have 9/4 minus
2.
8/4.
Oh, yeah.
You guys agree? I get a common denominator. You have calculators, so you can actually do this, and I'll never know. 9/4 minus 8/4 is
1/4.
1/4, which square roots to
1.
1 over 2. What's 2 times 1/4? Does 1/2 equal 1/2? Then both of these were legit solutions. All right? Congratulations, you get paid.
How much money?
You should have negotiated that before.
Oh my.
So in my solution set, both 1/4 and 2 are legit solutions. Was that okay? Now that was a pretty easy one to start with, your allergies to the fraction notwithstanding. So what if I then had the square root of 9 plus x and then minus 3 set equal to x? Another radical equation. Looks very similar to what we just did, right? So what's the first thing we have to do? Yeah, we got to get the radical by itself, which means moving the 3, right? You shoot your target in the middle of Fifth Avenue and you're not Donald Trump, you're not getting elected president.
Oh man. Yeah.
Just quoting. All right, so if I add 3 over, as you guys say, I get square root of 9 plus x equals x plus 3. Everybody's okay, right? Next step?
Square.
Square both sides. We pull the trigger, right? Now, a couple things to watch out for here. That's what you got to watch out for. An excellent question. And the answer is you do not square each term. You square each side. So that means I take the square root of 9 plus x and I square it. And I have to take x plus 3 and square it. That whole thing. All right? On the left, that's easy. 9 plus x, right? But what happens on the right? Yeah. You are supposed to FOIL it out because that means x plus 3, x plus 3. Now you could FOIL it old school, or you recognize that that is a perfect square trinomial. So that's going to be x squared plus 6x plus 9. All right? Remember, 1 squared plus 2 squared is not 3 squared. You can't just square term by term. That doesn't work. You have to do the whole thing out. All right? So if you write x squared plus 9, you're going to get an angry red mark on your test. Right? You'll know it's angry because it'll even like rip through the paper a little bit. Guaranteed. All right, so what kind of equation is this? Quadratic, surprise. All right, and our only method? Get it equal to 0, and we will factor out. So I'll have 0 equals, because it's easier to gather on the right in this case. I've got my x squared. I'll have plus 5x, and then, yeah, the 9's cancel out. So you can write plus 0, but plus 0 we don't have to. All right, so how do I factor this? Yeah, this has a GCF of x, so I'm going to factor out an x, leaving behind x plus 5. So 0 equals x times x plus 5. Now if I break it down, I get x equals 0, x equals negative 5. You guys with me on that? Is that okay?
Yes.
Are we done?
No.
Because we must
Check the body.
check the bodies. You will never forget, which is my goal.
I'm gonna write that on the test. I checked the bodies.
You check the bodies, you get paid.
Good grade.
All right, so we must check. I'm using CK as an abbreviation just in case anybody's like, what is he writing? It comes up. All right, so we got to check both of them. I'm assuming you're going to want to check,
0.
sure, 0 first. All right, it's funny, you have to check both of them, but you guys are like, let's start small and build our confidence. Sure. So that means I have square root of 9 plus 0, and then minus 3, and we're ever so hopeful that that's going to equal 0. Do you guys see what I did there? What is 9 plus 0? Square root of 9? That principal square root, I should say. 3 minus 3 is 0.
Oh, I see it.
What if I attempt x equals negative 5? So there we'll have 9 plus negative 5 under a square root, and then minus 3. And we're hopeful that that will equal what? Negative 5. Let's see. What's 9 plus negative 5? That's just 9 minus 5, right? 4, which square roots to?
2.
But 2 minus 3 is? And negative 1 is not negative 5. So guess what? Negative 5 was an extraneous solution. We only picked it up because we squared both sides. It wasn't there originally. Is that okay?
So when we write the test, we don't have to go 1.
Indeed. So in my solution set, I only have 0. No, you just go back and finish the job. It's all right. You know to pay attention there. All right. Now I want to kind of point this out. When you check, the reason it went wrong is only going to be because of a sign difference. If that had just been negative 2 minus 3, it would have worked, right? When you square, what is a positive when you square it? Positive. But what is a negative when you square it? Also positive. You just lost that information. That's how these extraneous solutions creep in. So it's only going to be a subtle sign difference that's off. So you want to be careful when you're checking. All right? Only 0 actually made it into our solution set. All right? You verified. You didn't report that negative 5 had been assassinated and then turned up at the police station. ID'd you in the lineup. All right. So what if I had the fourth root of 4x plus 1 minus 1 equals 1. How am I going to do this? It's a radical equation. So we got to get the radical by itself, which means adding that 1 over. So we get fourth root of 4x plus 1 set equal to 2. 1 plus 1 is 2. Good job. Occasionally I throw you guys a softball. Now what do I do? Raise both sides to the fourth power. What's going to get rid of a fourth root?
Fourth that power.
A fourth power.
I don't know how to say that.
Raise to the fourth power.
With that root.
Quad it.
Yeah. That root.
Quad it. So that means on the left I get
4x plus 1.
4x plus 1. And on the right I get 16. You guys agree? Now this time, we actually didn't wind up with a quadratic equation. This one's just linear. How would I solve? Subtract 1 and then divide both sides by 4. X equals 15 over 4. Except, check the body. It may look messy, but just because it looks messy doesn't mean it's dead yet. Right. So we're going to check. X equals 15 over 4. And I know that you're like hyperventilating, your palms are sweating now because you see this big bad fraction. It's not going to be bad because when I plug in, I do have the fourth root of 4 times 15 fourths plus 1 and then minus 1, and we're hoping that it all comes out 1. So when I multiply, won't the 4's cancel? So you just get 15. 15 plus 1 is 16. What is the fourth root of 16? It is 2, right? How do we know that the fourth root of 16, or at least the principal fourth root of 16 is 2? Because 2 to the fourth is 16. And 2 minus 1?
1.
1 equals 1 is true.
No way.
So that was a legit solution. In our solution set, we do have 15 fourths.
Are there ever going to be times when you only get one answer that you check it and it doesn't come out right?
Indeed. What would happen if your only answer doesn't work out?
No solution.
No solution. In fact, can we even get 2 potential solutions and neither one of them works out?
Yeah.
Yes. In which case it would be no solution. All right? All right. I do have an example, but it was a timely question, so. What if I gave you 2 plus the cube root of x minus 5 equals 1?
Subtract 2.
Subtract the 2. So I have the cube root of x minus 5 set equal to -1. Now what?
You gotta cube both sides.
Yes, now we're going to cube both sides. All right, we're going to raise both sides to the 3rd power. So that's going to get rid of that cube root on the left, right? So what do I have left on the left?
X minus 5.
X minus 5. And what's -1 cubed? -1. Once again, this is actually not quadratic. This is
Add 5.
linear. And it's actually a nice linear one. If you add 5, you get
4.
x equals 4. You guys agree? Now I'll let you in on a little secret here. All right? Remember, when we defined square roots, the even ones were the bad ones. The odd ones were fine, right? So, you do not have to check odds, right, when you have a cube root, for example. Because what is a positive cubed? Positive. What is a negative cubed? Negative. You don't get that loss of information when you have an odd power. All right? Checking's never a bad thing to do, right? But you'll never find an extraneous solution with an odd root. Okay? So that means 4, provided we did everything else right, is our solution. All right? Checking's never bad, but for the odds it'll be okay. I think that was in that lawyer speak that they attached on there, right at the bottom. Okay. Extraneous solutions potentially occur only when each side is raised to an even power. Are we ready to level up? Let's take a small level up first. What if I give you 2 times the square root of 4x plus 1 minus 9 equals x minus 5?
Subtract 9 divided by
Well, let's subtract or add the 9 in this case. We got a negative 9. Let's get rid of that. So I have 2 square root of 4x plus 1 set equal to x plus 4, right? You only add that to the right with its like term. So add the 9 to the negative 5, right? Now here's the thing. Originally, how many terms did I have on that left side? 2. That's not isolated, right? How many terms do I have on the left side now? I just have 1 term. So for the purposes of solving, this is isolated. Right? Your target's just wearing a scarf. So what? See a little scarf wrapped around, right? It's still a lone target. This is good news. If you divide it by 2, it's not wrong, but what's going to happen? You're going to make fractions, right?
I don't like those.
And you're allergic, so why would you cause that problem? Don't do it. So at this stage, the radical is isolated because it's the only term. We can square both sides.
Are we? Okay.
So I'm squaring both sides. But again, am I squaring term by term? No, I'm squaring the whole side. So square the whole side. 2 square root of 4x plus 1, all squared. And then x plus 4, all squared. So what's going to happen on the left? 4 times 4x plus 1. The 2 was outside of the square root, so it actually squares up to a 4. Meanwhile, the square root squares to just the inside. You guys remember, right? I emphasized that last time. It's almost like I knew this was coming. What about on the right-hand side? That's a perfect square trinomial. 3 terms, right? X squared plus 8x plus 16. Any of you guys struggling with that still? Right? I beat you over the head with it 2 tests ago, and we did it again last class. It never went away. Right? We did it in both directions, multiplying out and factoring. So there it is. Now multiply out on the left side. So if I distribute the 4, I get 16x plus 4 equals x squared plus 8x plus 16. So what kind of equation is this? Quadratic. And the only method so far? Get it equal to 0 and factor it up. All right? So again, it's just working out that the left side's the easier one to zero out. So let's do so. 0 equals x squared minus 8x plus 12. You guys with me? X and x, that's our only choice. What do you want to try for 12?
6 and 2.
6 and 2 works if it's minus minus, right? Does the last check out? Negative 6 times negative 2 is positive 12. So we get
X equals 6, X equals 2.
x equals 6, x equals 2 as our potential solutions. But check the bodies.
On the desk, we have to check.
Don't be that cocky assassin that's like, I don't have to. I'll shoot you down myself.
We have to check the 2 solutions.
Yes, we will check both solutions. Which one do you want to check first?
2.
Smaller numbers or friendlier numbers? Fine. If we check x equals 2, that means we have 2 times square root of 4 times 2 plus 1 minus 9. And then we're ever so hopeful that this turns out to be 2 minus 5. 4 times 2?
8.
8 plus 1? 9 square roots 2? 3. 2 times 3? 6 minus 9? Negative 3. 2 minus 5? Negative 3. So it worked. What worked?
2.
2. You're going to laugh, but that's a dumb mistake that people make. Then they'll go and put -3 in their solution set. But what were we checking? 2. Pro tip, don't. So now we're going to check x equals 6. So that's 2 times square root 4 times 6 plus 1 minus 9. And we're hopeful that comes out 6 minus 5. What's 4 times 6? Mumble, mumble.
24.
24. 24 plus 1?
5.
The principal square root of 25? 5. So that's 2 times 5 minus 9. That we're hopeful is 6 minus 5. 2 times 5 is 10 minus 9? 1. 6 minus 5? 1. It works as well. So in this one, in my solution set, yep, both 2 and 6. I put them in ascending order, but it doesn't matter, as long as they're both there. Was that okay? You guys still okay? Because now, right, you guys were little trainee assassins. Right? We had one target. Right? Now we're going to level up for real. Let's say that I give you the square root of x minus 2 and then plus 3 set equal to the square root of 4x plus 1. So it's a radical equation, but this time we have 2 radicals, 2 targets. Yeah, you got to do one at a time. Nobody's so good that their one bullet takes out 2 targets. Right? So we got to isolate one of them.
The easy one.
Which is the easy one?
X minus 2.
Isn't the second one already isolated?
Oh.
Right? I mean,
I didn't even know.
mathematically, if you go for the other target, if that target just peed you off, I don't know what happened, you'll still get the answer. That's okay. But we got one that's already down the dark alley, right? Take advantage. So what will we do? Square both sides. But again, do we square term by term? No. We square the whole thing. So I've got the square root of x minus 2 plus 3 all to 1 square. So equal to the square root of 4x plus 1 all to 1 square. Is that okay?
But doesn't that square get rid of that square root?
On the right, let's pluck the low-hanging fruit. Yes, where we just have a square root squared, they cancel each other out, right? So on the right, we just get 4x plus 1. But what's happening on the left? It's a perfect square trinomial. We got to FOIL it out. And actually, didn't we practice some of these last class? Again, it's almost like I planned for this, you guys. There was even a paycheck deposited last Thursday and everything. So this is a perfect square trinomial, in which case we need a squared, 2ab, and b squared, right? Trinomial 3 terms. So what is my a squared? X minus 2. What is my 2ab? 6 square root of x minus 2. You guys remember that? And then your b squared is 9. Neck action. You guys remember me doing this to you last time, right? You guys remember me doing this? Right?
Now I gotta get the new target.
Yeah. So the good news is we took out our first target. He was by himself, so nobody's alerted. But we got to clean up our mess. We actually only have one pair of like terms to combine. The minus 2 and the 9, right? So this means I've got x plus 7 plus 6 times the square root of x minus 2 equals 4x plus 1. You guys agree? Okay, so that was round 1. First target eliminated, right? What do we have to do now? Lather, rinse, reload. So we got to get our second target alone. So what should I do? Yeah, we'll subtract the x and we'll subtract the 7 over. So that means I'm going to have 6 square root of x minus 2 set equal to 3x minus 6. You guys with me there? Now again, you could divide by the 6, but that's going to make fractions and that's overkill. Optionally, however, do you see a common factor across this equation? There's a common factor of 3. So if I divide by 3, I'm not going to make fractions, right? But it is going to make smaller numbers. So if I divide everything by 3, I'm going to wind up with 2 square root of x minus 2 equals x minus 2. You guys agree? Now that we've got our target by himself, square both sides, right? Pull the trigger, square bullet. So 2 square root of x minus 2 squared set equal to x minus 2 all squared. You guys agree? So somebody who hasn't been speaking up as much, I'm going to pick on some of you shyer ones. What do I get on the left side?
Something.
4 times x minus 2.
All right, 4 times x minus 2. Do you guys all agree with him? He took the bullet for you, so to speak. The 2's outside, so it squares to 4, and then the square root, when it squares, comes out free and clear. What do we get on the right-hand side? X squared minus 4x plus 4. If you practice that formula, you're as fast at it as she is.
Me. That's bad.
So now I'll go ahead and distribute the 4 on the left. 4x minus 8 equals x squared minus 4x plus 4. And this is quadratic, so get it equal to 0 and factor. So 0 equals, that'll be x squared minus 8x plus 12. I think we saw something similar to this before.
Yeah, it's the one that we did.
So we get x minus 6, x minus 2. We get x equals 6, and x equals 2. You guys agree? So what should we do now? We got to check the bodies. Go all the way back to your original equation, which at this point you may have forgotten what it is, so here it is, because I'm going to copy and paste. So we go back to our original equation, square root of x minus 2 plus 3 is equal to square root of 4x plus 1. Who do you want to check first? Okay, bold, let's do it. So we've got, don't die, square root of 6 minus 2 plus 3. And we're ever so hopeful that that's going to be the square root of 4 times 6 plus 1. 6 minus 2? 4 square roots 2, if we're looking at the principal, plus 3. 4 times 6? 24 plus 1. And the principal square root of 25 is? 2 plus 3 does give us 5. So 6 worked. Next up, check 2, right? So we've got square root of 2 minus 2 plus 3. Hopefully coming out, square root of 4 times 2 plus 1. What's 2 minus 2?
0.
This principal, or in this case, even negative square root of 0 is 0. 4 times 2?
8,
8 plus 1?
9,
9's principal square root is?
3.
Is 0 plus 3 3?
Yes.
So this one works as well. So in my solution set, 2 and 6 work here as well. Are you guys with me on this? What if I give you the square root of x plus 5 plus the square root of x minus 4 set equal to 2? All right, so once again, advanced combat training. We have 2 targets, right? We got to get one of them by itself. And this time, neither one of them is by itself, right? So we got to do some maneuvering first. So which one should I move and which one should I go after? Move the square root of x minus 4. So we have square root of x plus 5 set equal to 2 minus square root of x minus 4. Is that part okay? So now you got that square root of x plus 5 by itself. Now, square both sides. So we got the square root of x plus 5 squared. We've got 2 minus square root of x minus 4 all squared. Do we square term by term? No. We square the whole side. Those of you that talk with me, you're going to do fine. Those of you that don't, you're going to blasé yourself right into an F. All right, so what do we do on the left? Blasé is a good word. Use it in a sentence someday. I was doing the left, sorry. So the left is just x plus 5. You guys agree? On the right, how do we square that perfect square trinomial? You got it. So what is your a squared? 4. What is your 2ab? So minus 4 square root of x minus 4. And then your b squared? X minus 4. So plus x minus 4. All right. What's suspicious? Neck action. Yes? You guys get it? No. You guys over here? In the back? Feels like I'm staring at you, I am? You guys over here? Any part of this you want to ask a question on? Any particular part of this?
I wanted to the variables.
You're okay?
Yeah.
Okay. All right. You don't have to lie to me. It's not to make me feel better. I want you guys to do well.
You do that because it's the difference of squares? Is that right? Or what is it?
This is that perfect square trinomial.
Okay,
Yeah. All right. So in this case, we have that very first 4 and that very last 4 that are actually like terms.
Yeah.
Yep. So I've got x plus 5 set equal to, I'll move that x up to the front, it's okay, minus 4 times square root of x minus 4. 4 minus 4 actually just zeroes out. So round 1, right? We took out our target, we cleaned up the mess, now we got to go at it again. So we got to get our next target by itself, which means subtract that x back over to the left. That's good news. I actually wind up just getting 5 equals negative 4 times the square root of x minus 4. Do not divide by that coefficient. It'll make a fraction. Right? Do you have a common factor you could divide out optionally? No. You can divide the negative if you want to, but it's just going to go to the other side. You can't get rid of it entirely. Right? Those pesky negatives just kind of hang around. Have I isolated the radical? It's just one term?
Yes.
Yep. Then I can
Square.
square both sides. So if I square 5, I get 25. On the other side, I'll get
Negative
16. Yeah, it's a good question. Why isn't it negative? Why is it positive? Because you squared it.
negative and positive.
Mm-hmm. And then we get x minus 4 just in parentheses. No more radicals. Free and clear, right? You could. I'm going to distribute. So 25 equals 16x minus 64. Well, this one's not quadratic. It's actually just linear. So how about add the 64 over. That's going to be 89
And divide by 16.
equals 16x. And then divide 89 by
16.
16. Does it reduce? 89 is odd, 16 is even, so not 2. 9 plus 8 is 17. That's not divisible by 3. Right? Neither is 16. If it's not even, it won't be divisible by 4 either. All right? Not every even is divisible by 4, but no odd is. All right? So this is what it is. 89 over 16. Nobody said it was going to be a pretty answer. All right? Get over it. But we have to check it. We got to check our answer. So we go back to our original equation. Square root of x plus 5 plus square root of x minus 4 equals 2. The good news, we only have one potential answer to check. The bad news is it's 89 over 16. So if I plug in, I've got square root of 89 over 16 plus 5 plus square root of 89 over 16 minus 4, and we're ever so hopeful that that's going to come out 2. Now you do have your calculators to do this for you, and that's fine. In terms of sixteenths, 5 would be 80 over 16. Four would be 64 over 16. So what is 89 sixteenths plus 80 sixteenths? 169 over 16. Go ahead and write it down. Oops. And 89 sixteenths minus 64 sixteenths, that's going to be 25 sixteenths under that radical. And those all happen to be perfect squares. The only one you might not recognize is 169, but that happens to be 13's perfect square. So that would be 13 fourths plus 5 fourths. And we are just hoping for that too. There is a common denominator, so you can add it. That winds up being 18 fourths, which is,
Yeah, I don't like fractions.
well, it's not a whole number, so it's not 2. Right?
Oh.
Notice, if that plus sign had just been a minus, what is 13 quarters minus 5 quarters? 13 minus 5 is 8, but 8 over 4 is, so it's just that sign being off. That's what I'm telling you. When it doesn't work, it's just because of one little sign being off that causes it not to work. So this is going back to a question we had earlier. I only had one potential solution here, 89 over 16, and it didn't work. So the answer is no solution. I either just write my solution set empty and sad, or in words you can write no solution. I don't know why I picked up an accent. It just did. All right. What if we look at the square root of 6 plus 5x plus the square root of 3x plus 4 equals 2. Apparently I was feeling that too.
Yeah.
I want you guys to kind of take the reins in this one and tell me exactly what I should write on each line. So what should I write for my next line? Square root of 6 plus 5x equals
Square root of 3x plus 4, or minus square root of 3x. 2 minus
2 minus
the square root of 3x plus 4.
square root of 3x plus 4. So I took that second radical and subtracted it over to the right. All right.
square both sides.
Now we can square both sides. And again, do I square term by term? No. How do I square? The whole side. So that's going to be a perfect square trinomial over there. So again, you guys take the reins. What do I write for my next line? 6 plus 5x, free and clear, equals 4
Minus 1? 3x.
Minus
Plus 1.
minus 4 square root of 3x plus 4. I don't know. I was kind of feeling you guys on that. Kind of came out mumbled. Continue.
Plus 3x plus 4.
Plus 3x plus 4. All right, that is that perfect square trinomial that we multiplied out. All right, so I could just combine the 4 and the 4. So for the next line, 6 plus 5x equals 3x plus 8 minus 4 square root of 3x plus 4. I did the cleanup for you. You're welcome.
What do you do? Oh, you
Subtract
moved the-
3x and subtract 8.
Uh-huh.
I just put those two like terms together. Again, a common mistake is people start squishing a lot more together. All right? This isn't Jane Austen and you are not Emma. Right? Which is what the movie Clueless was based on. Who knew that it was a literary classic? So, spoiler, matchmaking goes badly, don't do it. All right, so what should I do next?
Subtract 3x.
All right, so for my next line, what should I write if I'm subtracting the 3x and subtracting the 8?
Negative 2 plus 2x.
Negative 2 plus 2x, okay.
Negative 4 square root of 3x plus 4.
Equals negative 4 square root of 3x plus 4. Okay, so optional. First of all, that left side's not in descending order, right?
Right.
So I can rewrite it if I'm so inclined as 2x minus 2 equals negative 4 square root of 3x plus 4. It's optional, but it's a little nicer. Another option, do I have a common factor across this equation? So if I divide the 2 away, it is optional, but smaller numbers are nicer. What do I get?
X minus 1
X minus 1, again, that one might be so easy it's hard,
equals negative 2
equals negative 2
square root of 3x plus 4.
square root of 3x plus 4.
If you don't do that, will it still work out?
Yeah, you just have bigger numbers, and it reduces in the end.
Okay.
That's square both sides.
Now I can square both sides. So I have x minus 1 all to 1 square, and then I have negative 2 square root of 3x plus 4 all to 1 square. What do I write for my next line?
x squared minus 2x plus 1.
X squared minus 2x plus 1. So we got a perfect square champion up here. All right? Are you guys all as confident in your perfect squares? If not, you want to practice that. All right? I told you the first time we saw it, it wasn't going to leave you alone.
Equals.
equals
4 times 3x
4 times 3x plus
plus 4.
4. All right, I'll distribute. I'll take care of the cleanup again for you guys. So x squared minus 2x plus 1 equals 12x plus 16. Again, if you did not divide by the 2, you're just going to have bigger numbers across the board, but it'll wind up being the same. Yeah, this time it's actually more convenient to get the 0 on the right and bring everything to the left. So what shall I write? X squared minus 14x minus 15 equals 0. So what shall we do?
15 and 1.
All right. X and x, 15 and 1. How's that going to work?
16 minus 1.
The inside is negative 15x. The outside is positive 1x, right? That's going to give me negative 14x. And your last, negative 15 times positive 1 is? Negative 15. You guys got it, right? So my potential solutions? X equals 15 or x equals negative 1. All right. That enthusiasm just exuded from you. So we go back to our original equation, square root of 6 plus 5x plus square root of 3x plus 4 all equals 2. And who do you want to check first? Negative 1. So you guys prefer smaller over negative, right? So you're small negative people. Burn. Okay. So I've got 6 plus 5 times negative 1 under a square root. And then I've got 3 times negative 1 plus 4 under another square root added together. And we're just so hopeful for that too. So in that first square root, doesn't that mean 6 minus 5? But 6 minus 5 is, what's the principal square root of 1? 1. In that second one, isn't that negative 3 plus 4? Which is 1. And the principal square root of 1 is 1.
1 plus 1 equals 2.
Does 1 plus 1 equal 2?
Yes.
Are you guys confident in that?
Yes.
So then that one worked out. Negative 1 is a good solution. Go back and check 15. So we've got a 6 plus 5 times 15 under a square root. Plus, then we've got 3 times 15 plus 4 under a square root. Hopeful that that's all going to come out to 2. So 5 times 15, that's going to actually be 75. Plus 6 is 81. So 81's perfect square is 9. 3 times 15 is 45, right? 30 and 15 is 45. 45 plus 4 is 49. The principal square root of 49 is 7.
Nope.
Ah.
The number you took, I guess.
16
Yeah, 9 plus 7 is 16, which is not the same. Again, it's only a pesky little sign difference, right? But for a tiny little pencil mark, this would have worked. But that is the way things go when you are using even roots and squaring both sides. So in my solution set, I have negative 1. In our solution set, we have negative 1. Again, don't put the 2. The answer is the negative 1. It happens. It happens. You'll kick yourself all the way home. Let's do one more. Let's do one more. Let's say that I give you, what shall we do? Square root of 2x minus 1 plus square root of x minus 4 set equal to 4. At least it wasn't a 2 this time. It's bigger. There it is. So what shall I write for my next line?
Square root of 2x minus 1.
Equals 4 minus square root of x minus 4.
Equals 4 minus square root of x minus 4. Okay, you guys just go after the first target you see. Creatures of habit.
Square both sides.
All right, so if I square both sides, I've got square root of 2x minus 1, all raised to a square. And then I have equals the 4 minus square root of x minus 4, all raised to its own square. Do I square term by term?
No.
No. We square the whole side. All right, so first two rows, take a break. What do I write for my next line? You guys are good. You guys are good. I want to get some of those people that look like they're like bread, milk, eggs, thinking what they need to pick up on the way home. All right. Some math would be good too. What do I write for my next line, guys? 2x minus 1. You did pick the low-hanging fruit. Good job, good job. But what does it equal? 16 minus 8 square root of x minus 4. Okay. Plus x minus 4. Good job, good job. All right. So if I do the cleanup for you, then 2x minus 1 would equal x plus 12 minus 8 square root of x minus 4. You guys okay?
Mm-hmm.
And now we rinse, repeat. What shall I do?
Reduce by 2.
You have to get that.
All like terms?
You're trying to isolate that other radical, right? So what do I write?
X. X minus 11.
I was giving 13.
That's all right. We're here to learn, right? You participate aloud in class. You're doing good. You're doing good. So we get x minus 13 equals
Negative 8 square root of x minus 4.
-8 square root of x minus 4.
Square both sides.
All right. You're trigger happy over there. We will square both sides at this point. There wasn't anything common across the equation. So we will just go ahead and square both sides. So what happens? X squared minus 26x plus 169, since I actually just showed you that square a minute ago.
169.
Equals 64 times x minus 4. Are you guys on board? All right. Girl, you've been paying $100 an hour to use your phone. You guys over here? Now what?
Distribute the 64.
If I distribute the 64, x squared minus 26x plus 169 equals
64x.
64x, and that's where you guys give up the ghost, huh?
I don't know what 64 times negative 4 is.
256?
I do now. Thank you.
It's easy. So times 60, that's 240, and 16 more is 256.
Well, we should have divided. We didn't have like terms to.
No, unfortunately, there was no common factor across the board. All right? This is you learning the hard way that bigger is not always better. All right? Sometimes those numbers look scary, but you got to live with them. And next up, x squared minus 90x, okay? I heard it. Plus 425, set equal to 0.
Now you gotta factor that.
Yes, indeed.
Good luck.
42, 90.
That's a little rough.
look, it's only x and x, so that makes our job a little easier. We need something that's going to add up or subtract to 90. Right? In this case, because it's positive, we want it to both add up to 90. All right?
We can use the quadratic formula.
We haven't talked about that yet, so no.
No, we can't. Not right now.
I promise you they will all be factorable. What do you want to try? What do you think is going to go into 425?
5? Is 5 going there?
Yeah, sure. So divide 425 by 5, and what do you get? You can do that in the calculator. If you take 425 and divide it by 5. Okay. So 85 and 5 give us 425. Does that give me 90? Oh, see, you guys are like, wine, wine, wine. And it actually was the first one you tried.
Oh my god. I hate myself so much.
And they will both be minus, so that they multiply to a positive 425, but add up to a negative 90x. So x equals 85, x equals 5. But
Check the bodies.
you got to check the bodies. Do not forget, you will not get paid. And after all that work, you want to get paid. Just saying.
85.
All right,
85?
let's do 85 first.
85 is?
So if we plug in, that's going to be 2 times 85 minus 1 under a square root, plus 85 minus 4 under a square root, and we're hopeful for a 4. So 2 times 85, 170 minus 1, and the principal square root of 169 is 13. 85 minus 4, 81, principal square root is 9. But 13 plus 9,
There's no way that's going to equal 4.
it doesn't. Notice that if it had been minus, it would have worked. Right? That's just how that happens, if it happens. All right. So you guys ferreted out the stowaway. You're good at that. We still have to check 5. So we get 2 times 5 minus 1, square rooted, plus 5 minus 4, square rooted. And does that equal 4? Let's find out. 2 times 5, 10 minus 1. The principal square root of 9 is 3. 5 minus 4, principal square root of 1, 1. Does 3 plus 1 equal 4?
Yes.
Then that one works. So in my solution set, what do I put? 5.
Oh, dang. See, look, there you go.
See, I push you into the pit, and so you die on the spikes at the bottom, and you learn before you go into the test. All right? By the time you go into the test, hopefully now you'll know to check for that. All right? All right, so let us do one more. You guys asked for it. Let it not be said that I don't deliver. Let us say that square root of 2x plus 3, square root of 3x minus 5 added together equals negative 1.
Square root of 3x.
You want to move it
Oh, yes.
or kill it? Okay.
No. The other.
You know what? He feels so strongly about it, he gets his way. We'll move the first one over. So we wind up with square root of 3x minus 5 set equal to negative 1 minus square root of 2x plus 3.
Can you just rewrite that as plus 1? Get rid of all that? As square root 2x plus 3 plus 1?
It's still a minus 1, whether you move it to the front or the back. How could you make it a plus 1? Because you can. When you square it, it's going to take care of it. But if it really bothers you, you could multiply both sides by a negative 1.
Yes.
That's okay. If I multiply both sides by a negative 1, negative square root of 3x minus 5
Square root. Oh no, honey. No, 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 no. I'm not okay.
equals 1 plus square root of 2x plus 3. That's perfectly fine. If you went ahead and squared it, you'll get to the same place. But this is good too.
I'm gonna vote against it.
What's my next step then? Square it. So either way, we're going to get rid of it. I just appreciate you guys are kind of giving me some direction. Now you're teaching me how to assassinate the target. All right. No, no, no. You got to aim for the heart. All right, all right. That's what you guys want. This must be an X, right? So what do I get on the left? 3x minus 5. What happened to the negative? Negative times a negative is positive. So it's just going to give me 3x minus 5 free and clear. You guys agree? If you didn't move the negative over, you still get that, right? What do we get on the right side? 1. That was the easy one.
Minus square root of 2x. Oh, 2, yeah.
Plus 2.
X.
Square root of 2x plus 3. That's your 2ab, right? That's your 2ab, and then plus 2x plus 3. Now, if you guys had kept the negative, can you see how this would square to the same thing? Because negative 1 would still square to 1. And then for your 2ab, a negative times negative becomes,
Positive.
that's positive 2 square root of 2x plus 3. And then your b squared is plus 2x plus 3. So that's okay, even if you didn't choose to move the negative. I think moving the negative was elegant. Made it look a little cleaner. You exchanged 2 negatives for 1. That seems like a good deal. All right, I'm going to let you do the cleanup. What should I write? 3x minus 5. Oh, you went ahead. Go, girl. Take out that target.
2x plus 4.
2x plus 4
2 times the square root of x
plus 2 square root of 2x plus 3. Some of you guys are becoming proficient at this business. That's good. Next step,
X.
x
x
Minus 9.
minus 9
2 square root of 2x plus 3.
equals 2 square root of 2x plus 3. Is there anything common across that equation? No. I mean, you could divide by 2 if you want, but you make fractions. And while that's mathematically correct, you are going to get lost in fraction Hades. All right. So then what do I do?
Square both sides.
Square both sides. If I square both sides, on the left, x squared minus 18x plus 81 set equal to?
Oh, yeah, 4. And then the other part.
That's why we're here. We're here to learn. It's 4 times 2x plus 3.
No, you're not going to fail this test. You're doing so good. It's okay. You're getting there, I promise.
You guys are great. You guys are great. 7 o'clock classes can go one of 2 ways. All right?
Tonight we're good.
No, you guys are good. Yeah, let's distribute that 4. So we get x squared minus 18x plus 81, set equal to 8x plus 12. And it's quadratic again, so bring it over.
X.
X squared
Minus 26.
minus 26x
69.
plus 69 equals 0. And
Factor.
let's factor this. X and x, the easy one, right?
13. How many times is 13? 2. No, it's not. 69. 3.
Nope, that didn't work.
323 words.
Okay,
I don't know if that's any much fun.
well, let's try. So 3 and 23, that does multiply to 69, right? How can I get that to a negative 26?
Negative, negative.
Negative and negative. Does that work out? Okay. Negative 23 times negative 3 does give me the positive 69. So we get
23 and 3.
23 or 3 as our potential solutions. But
Check the bodies.
I like how you sang it. You're the singing assassin. You even have a calling name now. So here we go. Back to our original. Square root of 2x plus 3 plus square root of 3x minus 5 set equal to negative 1. Who do you want to check first? You guys are bold. I like it. You're going to knock those big targets out first. So 2 times 23 plus 3 under a square root plus 3 times 23 minus 5 under a square root set equal to negative 1. 2 times 23, 46, plus 3, 49's principal square root is 7. 3 times 23, 69 minus 5, 64, which has 8 as its principal square root. 15 is not negative 1, so that didn't work. All right, again, if it had just been a minus in there, it would have worked. So we go back and we try 3. I'd forgotten I had to check. So 2 times 3 plus 3 under a square root plus 3 times 3 minus 5 under a square root. We're hopeful for that negative 1. 2 times 3, 6 plus 3. 9's principal square root is 3. 3 times 3, 9 minus 5. The principal square root of 4 is 2. But 5 is not negative 1 either.
No solution.
Yes, indeed. After all that, there is no solution to that equation. Nothing will make it true. Everything makes it false.